Hello, sir.
Okay, ma. So,
Sir.
good morning, everybody. Sumita,
Yes, sir.
I think 30 participants are there.
Yes, sir.
We will start. Good morning, everybody. I hope that all the participants are enjoying with the talks during the last 3 days. So, today we entered the, I think, fourth day of our MTP. So, today also we have two eminent speakers will deliver talk on two important aspects. One from morning 10 to 12, another one is from 2 to 4. So today in our midst, we have Dr. Geeta, software engineer, India Private Limited, so from Pune. So today, in spite of busy schedule in industry, software company, she has accepted for delivering talk in our
Hello, sir.
handling the field.
Sir, your voice is breaking, sir.
Breaking.
Yes, sir.
So he is handling the hidden of economics neural network for natural language processing by using the general adversarial networks (GAN). So thank you, madam. Now I request Sunita, PhD scholar from NIT Warangal, she will introduce madam.
Okay. Thank you, sir.
Sunita.
Yes, sir. Thank you, sir. Good morning. Good morning to all the participants. Welcome to the day 4 session in this FDP. Today I introduced Dr. S. Geeta Govindam, software engineer, India Private Limited, Pune, Maharashtra, India. Ma'am has 10 years of teaching and 2 years of industry experience. Ma'am currently working as a software engineer level 4, India Private Limited, Pune, Maharashtra, India from June 2020. Ma'am worked as assistant professor in GH Roshini College of Engineering and Management from June 2014 to May 2020 and in Abhinav Education Society College of Engineering from 2010 to May 2014. Ma'am successfully submitted PhD thesis in Artificial Intelligence domain, Vellore Institute of Technology, Chennai. Ma'am worked on projects Whirlpool, India Private, such as Global Position System Project, Part Tracking Application as a ThingWorks developer and testing team member. Ma'am has technical skills on Agile methodology, ThingWorks, Waterfall model, Jira tool. In academics, ma'am taught different subjects such as operating system, cyber security, machine learning, iOS development, and Android development. Ma'am taken guest lectures in various educational institutions and keynote speakers at international conference organized by IBM Dubai. And the project reached to grand finale round in Smart India Hackathon 2018. Ma'am attended more than 30 workshops in various industries and colleges. Ma'am published more than 25 papers in quality journals and conferences and one copyright file. Thank you. Thank you, ma'am, for accepting for giving a valuable lecture in this.
Now I request Geeta ma'am.
Yeah. It's really a great introduction, ma'am. Thank you so much, and thank you so much, Dr. Kishore sir, for giving me an opportunity to join with your participants. So, can we start, sir? Or
Yeah, you can start, madam.
yeah,
You can start.
okay, sir. Okay. So, first of all, I would like to welcome all the participants, and I would like to have a pleasant morning to all for joining today's session. Actually, it will be an interactive session so that we can, if anybody is having the research in the same domain or they are pursuing their PhD in the same domain, then we can clarify their doubts as well. So, first of all, I would like to welcome ICT Academy organizers and NIT Warangal organizers team. Along with that, the Kankriya Institute of Technology and Science team. So, I would like to welcome all and all the participants for this session. So, let me share my screen so that we can start the presentation. So, is my screen is visible, sir? Or
Yes, ma'am.
yeah, okay, ma'am. Thank you so much. So, okay. So okay, so my topic is future perspectives of recurrent neural convolution neural network for NLP by using GAN. Actually, my research was on natural language processing. Like I'm working from last around 6 years in my MTech. Also, I have taken the same area and not only NLP, but along with NLP, I have worked on neural network aspects as well. So that's why I would like to share some of my work as well, and what we can do in the future in the same domain of convolution neural network. Nowadays, as all of us know, that this convolution neural network is a trending era in not only in the educational institute but also in the industries as well. They are focusing maximum on this convolution neural network. So it will be very useful for educational institutes as well for developing their research and for the industries, so that whatever the functionalities the industries are carrying out right now by using other techniques, so it will be easy for them by using this new concept of convolution neural network. So first of all, I would just, I think most of you know what is NLP and what is GAN. Some of you might be not knowing that. So just I want to tell you about NLP as just general thing. That is, it is nothing but the natural language processing. So as we can see, there are like multiple robots are available, which are working as like a human being. Means they are like speaking as like human being, or they are doing the task as like human being. So but before they are working, we need to train them as like a human being. So we need to fetch some speech, or we need to train them with the language. Then only they can try to grasp whatever human beings are saying. Or we can take an example of Alexa. Now what is Alexa? Actually, Alexa, for Alexa also we need to give the details like uh, data. We have to train the Alexa with the text, or we can say some language which he can understand, that Alexa can understand. So that the similar way the NLP works actually. We need to train our system with like we can say the text or speeches in the language from so that we can get an output from the system to which we are going to train whatever output we required. So that is only the NLP, and the GAN is nothing but it is one of the technique for convolution neural network, that is called as generative adversarial network. So this GAN is can be used not only in the speech synthesis but in other things, like other researchers are also using this for their development, or for finding out the fastest way for getting their outputs. So here I'm concerned with the GAN, that is the generative adversarial network. This GAN mainly focuses on if we are giving an input, for example while considering an NLP, or we can take any image. Suppose I'm giving any small image to the input to the GAN, general GAN architecture, then it will reproduce a multiple, like thousands of the varieties, or we can say thousands of the different scenarios of that particular image. Or while considering the natural language processing, if I want to I want a multiple speeches. Okay, speech database I want to create by using GAN. Then what I will do, like I will provide to the system raw audio. Like for example, I want the multiple, or I can say thousands of the various different varieties of any particular word. For example, hello word. Suppose I'm giving my system that hello word as an input, then by using GAN I can generate a thousands of the varieties of that hello words. Like it, these varieties are like, suppose I'm giving in my own voice, or in my own voice, then that system will generate the audios in such a way that, like the voice of small child, voice of middle aged person, or voice of like older person, like that multiple like thousands of the varieties are generated by the GAN. So what is the main use of this GAN is that we can generate thousands of outputs, and we can use that outputs for training our system, so that once we have trained with the thousands of the hello words variety, so then our system can easily recognize if any other person tries to test our system. So that is the main motto, and which is possible with GAN only. If we use the general techniques which are already available, then we cannot get the outputs like speeches in this thousand or multiple amounts according to the inputs our we are taking. So but here the one the like technical aspect here come. As an industry person, I just want to tell that, like if we have the system of like we for our system we need a larger processors for using this GAN. Like for example, right now in Apple PCs we are having large amount of like we can store large amount of data, and it is having the big processor capacity. So in such a system we can develop these GAN methods. So because database which we are providing or inputs which we are providing are also in the large amount. Okay, so these are some of the contents which I wanted to cover, like whatever what was the previous things present in NLP, or we can say before coming to this convolution neural network, recurrent convolution neural network. What was the system, what were the systems present in normally people were using, that I wanted to highlight. And after that, now in the future or current aspects, so which things are there available and which can be developed in the future, so that I wanted to just convey by using this seminar. So first of all, we will just go through whatever techniques which are already available for speech synthesis, and which can be like by using GAN or recurrent neural network, how we can develop or we can improve the speech synthesis technique, which can be used in multiple applications. So first of all, I would like to tell you about the speech synthesis. Most of you, all of you already know what is speech synthesis, like synthesis of a speech if we are providing an input to the system. So here the people are considering speech synthesis of two types, like not two types, there are multiple types, but we will focus on these two right now. So generally, speech synthesis concepts comes under the thing like we are providing the text input to the system, and system will generate the speech. This is a simple scenario. Like this is a part of NLP. So we are providing text to our text input to our system, and that system will generate a speech. So this is a straightforward scenario. And other thing of speech synthesis which can be used in for generation of multiple larger amount of data set, like large, if we want a larger speeches or large the speeches spoken by a larger amount of people, we can say. So in that case, the second aspect can be used, that is speech synthesis from given input speech. As I told you in the first slide, that is GAN is normally that is generative adversarial neural network is generally focusing on this second aspect, that is generation of variety of speeches from given single input speech. So this is the second aspect of speech synthesis normally. And this is a general architecture. I just wanted to tell how the speech synthesis occurs in the first aspect, that is text to speech synthesis. So as I told you, we are giving either sentences or the words in larger quantity to the system, and then system will try to do the morphological analysis of that words or the sentences. What is morphological analysis here? That is nothing but like if there is any noise or any the things which are present, or if you want to tokenize the word or sentences, so that is all this comes under this morphological analysis. Once tokenization and noise removal will done, the speech recognition can be carried out, like what is that word actually, and then the system will try to generate the speech. Once system will recognize the speech, it will try to generate a speech. So this is just a general architecture which in normal NLP the people are using for the speech synthesis purpose. So now for just for overview purpose, I just wanted to tell what are the like general techniques which are available here uh, for the natural language processing for converting the text data into the speeches. So these are some of the researches carried out with the normal way, like whatever I have explained in this general architecture, without using any neural network or without using any the concept of artificial intelligence. The people were using initially. Still, some of the people are doing the research in this general, like, straightforward system of text to speech conversion. But whatever the quality and the quantity of outputs we are getting is actually low. So here some of the papers I have just collected. Mm. So this is the first paper. I will just go through overview these papers to you, so that you will come to know what were the drawbacks in that case, and why we are going to the convolution neural network or artificial intelligence concepts right now. So this is the first paper, that is translation of text to speech conversion. As I am from Maharashtra, I have just why I have collected such a paper, because I am normally speaking the Hindi language, so that's why I have a lot of like papers on this. Not only Hindi, also in Telugu and some the Tamil language, or I have some papers on it. So if anybody required it for their research, I will be there to help. So in that case, you can see here, it is a general text to speech technique, but the disadvantage for those papers are the accuracy what they got, like for translation of Hindi text to speech conversion was very less. That is around like only 45%, which is it means it is not giving the speech which we want, like human can understand. This the speech which was generated was like system generated speech, like what like it was showing like our system is speaking. It's not showing like the human is speaking. So that are the drawbacks in the first paper. Again, one more paper I have, that is this is a Marathi language text to speech synthesis. Normally in Maharashtra we are using this Marathi language, so it is our mother tongue. So in this paper they have also used the normal approach for conversion of like text to speech, like they have just only collected some audios in their system, and they have mapped that audios with the input text only. So that way they have done. So again here the problem of naturalness of the speech was not there in this case. So then again, the if we cannot use such a systems for like industry purpose or for any applications, we cannot prefer such a system. So that were the drawbacks in that case. Again here the development and implementation of Hindi text to speech synthesis system. Here again they have just improved their system by using hidden Markov model, for which is used for automatic the speech segmentation. Like speech segmentation means here, like whatever, suppose we are providing the inputs in the sentences, or we can say the words, so the segmentation of those words are done by using HMM. So that new concept they have brought. But again the problem here was that they were not able to map their script with the like English Devanagari script to the English script. So that was the issue in that case. Sorry. Similarly, these are some of the papers. Now, see, you can see here the fourth number paper. Here they tried to correlate their text-to-speech system with the neural network. That is, they have used the novel approach for lip reading based neural network computational techniques. So here, what they have done, like suppose I am the person and they are collecting the speech from my side, like I'm giving the input to the system. So they have just done the video. They have take video acquisition, and then according to the face and mouth, like there are some coordinators they have stored in their database, like lip coordinators we can say. So those lip coordinators are stored in their database, and from that they have just tried to recognize what that person is trying to say. Okay, so such a database they have maintained here in case of this neural network technique, lip-based reading. So suppose, for example, person is saying hi, then which coordinators are moving of his lip. So in this way, they have tried, they have maintained the database. Like these coordinators are moving means this word is hi. So like that, they have maintained the database, and they tried to map the system and get the speeches from that. So, but here again, it was giving the good performance. Actually, it was in 2016. But the problem was that again, it is a complex method. Why it is complex method? Because each time they need to maintain the record, like the coordinators of their lips, and that coordinators of lips are again, if they have stored some 10 words or 20 words or thousands of words, we can say, if person is saying the new word, the system try to find out that what that particular person is saying, because that word is not stored in database. So that was the issue, like it is a complex method to every time, and time consuming method. Every time the system need to detect that the coordinates of lip of that person and get the output. Okay, but it was having good accuracy as compared to the normal, like general text to speech techniques. Again, the next method, that is HMM based speech synthesis. So here they have used again the HMM for synthesis of speech. So here the main disadvantage again, here they got that the speech was having less naturalness, so it is not closer to natural speech. Again, as we can see here on this 2016, the lip reading based on neural network concept. Again, the some of um, the same person has developed the new system, that is lip reading approach on the neural network in 2019 as well, with some customization. But the issue was that again here, while taking the video of that person, now as we have seen here, like they were collecting the videos, and from that videos they were like recording their coordinators of the lip. So here the issue again in this paper, in this work, they found that there is unbalanced lightning. If there is no proper lightning or uneven, we can say illumination is there. Means there is no any proper like lightning or intensity equalization is maintained. So in that case, the video which they are recording, so that was not getting giving us a correct output. Okay, so that issue they found in 2019 again, if we use the neural network for lip reading approach, but the accuracy or the naturalness was good in that case, because whatever the techniques they have used, it was like neural network, so it was giving like output as a normal human speech. So these are some of the just techniques which were available for this general, like straightforward text to speech synthesis. Okay, so after that, I would like to just tell you about what are the some of the methods people have implemented for this speech synthesis. Now the second approach, as I have told you in the second slide, again I will go there so that I can tell you. So the second approach is for like synthesis of speech from a given input speech. So in that case, we can just refer some of the generative adversarial networks algorithm which were developed by some of the scientists or the researchers, we can say. So here we can consider the system has given an input as a speech, not a text, to generate a multiple speeches. Okay, so just for if some of the people are not knowing about the GAN, I just some introduced here the GAN. In the next slides, I have the proper architectural diagram for GAN. I will tell you at that time also. So you can see here the GAN is nothing but the it is called as a generative adversarial network. So what this generative adversarial network will do? Here, generally it consists of the two main components, that is the generator and discriminator. So whenever we are giving as an input to our system raw audio, as I told you, raw audio or input audio we are giving to our system, then these generators and discriminators are having the main role. These are the main two components which are present in every GAN architecture. So these two components are trying to generate a multiple speeches, and how they are trying, that I will tell you. Okay, so here some of the papers, I just wanted to papers, or we can say the works which were there present in this GAN already. So I just wanted to highlight some things here. So you can see in this first paper, this is generative adversarial neural network paper. So here normally they have not worked on the speech methods. they have worked on the images to generate a high dimensional or the multiple images from a given input image. If somebody is doing the research in image processing, or they are trying to generate a multiple images of a single image to prepare their data set, they can use this GAN there also, like generative adversarial networks, advanced technique which are currently available, so that can be used, I can say, like for image processing as well, so that we can give an input image to the system, and system will give a multiple variety of images, or various aspects are covered in multiple variety, so that we can use this as a data set for your research if you are doing in the PhD. So here the image normally they have given as an input image to the system, and as I told you, generator and discriminator are two components which are present, so they are generating the multiple images. But here the disadvantage was that, as I told you, these two components are there, generator and discriminator. They need to synchronize with each other to generate a like multiple outputs. But the synchronization problem was there here in the first research, you can see. But the accuracy was actually good, that is around 82%. But if that synchronization will not occur, then whatever outputs sometimes they are getting, that was improper, means whatever images are generated, that was improper. So that was the issue. In the second paper you can see the adversarial audio synthesis. So here, see, for the GAN, not only a single generative adversarial network is present. Multiple researchers have developed a multiple types of GAN, and they have given their own name. Some of the researchers have given their the different names for that GAN. So here in the second paper you can see they have introduced the wave GAN concept, which is for unsupervised synthesis of raw audio. Means here this concept is used if for unsupervised synthesis. So they have given an input as in raw audio. So again, this paper, in this paper they have not taken the speeches of a human being, so they have worked on the speeches of like bird sounds, we can say, like how the birds are sounds are present, and some of the piano notes, like, and the whatever the musics, or we can say the sound or audios are coming from the piano, so they have worked on that such a sounds. Means the GAN can be used not only for the human speech synthesis, but it can be used for like other things also. We can say the bird sounds, piano sound, or any other types of audio. So on, if somebody is trying to do the research in some other audio, so they can also use this GAN method, for generative adversarial method, for generating a multiple audios. So here the problem was, what the problem they found by using waveGAN. So waveGAN is one of the technique. I have some of the results of waveGAN also that I will discuss with you today. So so waveGAN, the problem was with waveGAN was, like, if we are providing the audio of more than 1 second or more than 2 seconds, so suppose audio of 2 seconds I have provided, then it was not giving an output properly. Means this waveGAN was giving an output for the audios which are having only 1 second duration. So that was the issue in case of waveGAN, which was implemented in 2018. Before that, also some researchers have tried to develop this waveGAN. Okay, so if somebody want to ask any thing, you can stop me in between, no issue. Yeah, otherwise I will say and say. If you want to, like, clarify something, you can ask in between. So the one more method in way GAN was introduced in that was WaveNet. That concept of, this is also the concept of generative adversarial network. So here this WaveNet they have introduced for making the audios, as I told, from the given raw audio. Again, they have worked on the music notes, not human voices. So they have taken as an input music notes to generate a high quality of multiple music variety of music notes of the given input. So, but the issue was that the fidelity achieved from this output was not as per the requirement, like whatever requirement they want, like how the music notes should be generated. So they have not got that output here. Okay, so as I have from this slide, I just wanted to tell that this neural network, that is we can say current concurrent neural convolution neural network, can be used not only for the human speeches for generation of data set or audios, but it can be used for images, for other types of audios like bird sounds, or I can say piano notes, or any other instrument sound, or any other audios. We can use this GAN technique if somebody is doing the research in the same. Again, there are some other GANs are also present right now. So that is one of the GAN is Wasserschen GAN. So it was implemented in 2018. So in this case, in this particular Wasserschen can was having one issue. The researchers were found out that it is the quality output, whatever the speeches they are getting, was like degraded. So it was having the less quality. So it reduces the performance of output. That is around 60% performance output they have received from this Wasserschen GAN. Okay, and one more GAN that is I want to discuss here, which is present right now. That is cycle GAN, we can say. So this particular cycle GAN was gated with the convolution neural network and trained with the identity mapping laws. So here, if we use the non-parallel data, like the data which is not the similar or which is non-parallel, we can say, so it was not giving the good performance. So that was the issue in this cycle GAN. And one more again that is I want to tell you here is that GAN TTS, we can say, like for converting text to speech. So text to speech synthesis. So the name was given was GAN TTS. So here, if a limited data set was used, they have used the limited data set, so that whatever output they are getting, were also having the limited accuracy, because all of us know that if we are doing any research, we need a large amount of data set, then only we can generate a proper output as per our requirement. So that was the issue they found over here. So as I told you, like these are some of the GAN methods which are available. Other than these, also multiple methods are also available right now. But I just try to cover up some of the methods over here. So you can do the, if somebody want, he can do their review, or he can search out these types of GAN on the good quality journals. So the WaveGAN, WaveNet, and Wasserschen GAN, Cycle GAN. So all these are the types of neural network techniques which are used for generation of speeches, images, or any other techniques. We can use this. Okay, so as at the start I have mentioned you the general method for natural language processing, that was text to speech, this one text to speech synthesis. So I just wanted to share some of the why this uh, text to speech synthesis was giving a very less output, like because it were these methods are only the straightforward methods, and they are not having, like system will not get any intelligence, so that system can perform by their own. So that was the issue. So there are two methods I just wanted to tell you here. And their first method was like TTS method, that is text to speech method. So here, as less amount of inputs are taken, suppose we can take, so in this method they have taken like 410 words as an input. Okay, so and one more method, that is automatic speech conversion for a simple Hindi words, we can say. So in this method what they have done, like they have taken the words as an input, and in the database they have just only stores the like connectors and the words. Suppose for every language we have like consonants and the vowels, so they have collected those consonants in one data set, and some connectors, like we are giving the connectors, so those all those connectors are also they have stored in one data set. So normally if we are giving an input to the system, suppose this is one word we are giving as an input to our system, so then that word gets splitted, like they have splitted by using this automatic speech synthesis technique. They have splitted that word and their connector in the system, and then system will try to map these splitted words with the data, like the connectors or the vowels or the consonants which are stored in the system, and then the system will come to know about what that word is actually. And after that, whatever output they are getting, that will be mapped with the speech data set which is stored in the system. So this is a straightforward method. You can see here again I have mentioned in this algorithm also the same method. Suppose for example we have taken this word. This is a two-letter word we can say. So suppose I have taken this two-letter word as an input, and then whatever if that system need any pre-processing, that can be done. After that, by we have one library in Python, that is called, as most of you might be knowing, this GTTS library. So this GTTS library will used for tokenizing the words input which we have provided to the system. Then after tokenizing or dividing that words into the part, then that is converted into the phonemes, like small phonemes will get as an output, and then that phonemes are matched with the data set of the speech, and then speeches are generated. So these methods are like previous methods before neural network comes into the existence. So this is a general algorithm for it. So this is, as I told you, this GTTS library is used for Python programming, which is one of the API which is present in Python. So for which is used as a tokenizer for if we are giving any input word to the system. Okay, so this is just for example whatever I was trying to tell you, that I have just taken some screenshot from one of the, like I have worked on it also, and some screenshots I just taken from some researchers also. I have done this some of the work on this method as well. So you can see here this is one sentence as an input is taken, and as I told you, these are connectors. These are the 15 connectors. Suppose in any language. Here I have considered our Hindi language. Suppose so you can use here the Tamil yeah, consonant and the vowels. Okay, so that are mapped with the English words directly in the database, and connectors are also given some numbers for mapping purpose, so that system can recognize whatever inputs are provided. Then if we provide this input to the system, these connectors are mapped, then the system will get this output as an internal output, so that system can try to recognize the word. Okay, and then whatever output they have got, so that is mapped with the wave file, or we can say the audio file which are stored in the database, and then we will get the output. Okay, so these are just some results for by if we use the general text to speech techniques and GTTS method. So GTTS was performing best because in Python this library is available actually, these GTTS libraries which is directly giving an output, or which is directly performing the without any human efforts. We can tokenize the given input word. Okay, so that was that. These are some sample inputs I just have collected for showing you, like according to the string length. So these are the strings. So according to the string lengths, like in how much amount of time we are getting the outputs by using general text to speech methods. Okay, so these are just a comparison. Then once we get our speech from the system, in that after getting the speech from the system, we need to like recognize, the system need to recognize that speech, like whether after generation of that speech from the system need to recognize like what that person is trying to say. So there are multiple methods are available for that yeah, recognizing the speech. So here some of the GTW, which was the previous method, that is dynamic time warping algorithm. Most of the people might be knowing this. What is this dynamic time warping algorithm? So this dynamic time warping algorithm is trying to compare the speeches. Like suppose, for example, it is trying to find out the sequences in between the two speeches, so that it will come to know about like whether these two speeches are matching or not. Okay, so for that purpose, this recognition purpose, these methods are used. And again one more method was there is there, that is customized dynamic time warping algorithm. In that they have introduced the two concepts. for mapping or matching or recognizing the we can say audios. One is wildcard pattern they have introduced. This is a new method, new concept they have introduced. And second is auxiliary matrix concept. So what are these doing? So wildcard pattern is actually used for the patterns, like few of the patterns of the words, or we can say the not words, speeches are stored in the database, so that in system it will be easy for the system to recognize the word which are generated by the system with the pattern, instead of doing going through complete algorithm. If the system will try to map with the generated speeches with the actual means, like recognizing the speeches. So wildcard is used to recognize the patterns. And auxiliary matrix they have implemented because suppose our system suppose we are performing the task at the high level, like we can say in the industries, we are using this dynamic time wrapping algorithm normally for performing larger applications, like comparison, or we can say recognizing the speeches at the larger level. So in that case, what problem is occurring? Sometimes the system may get stuck up in between, and whatever work is completed till now get lost. That work get lost. So for that purpose, the auxiliary matrix concept was used. What this auxiliary matrix will do? It will try to like the store the candidate paths. Candidate paths means what? It will try. It is working as like a backup. Like suppose we have reached to this particular stage, the system will try to store that stages at after every equal interval of time, so that even if our system gets fails in between, in case of larger application, we will get the previous things which we have done. We do not need to start from the start for recognizing. So that was the main motto of this customized dynamic time warping algorithm. So now I just wanted to introduce a few of the data sets which we can be used for the speech synthesis technique. Uh, One is one data set which is that is called as, like most of the people are using this data set, that is speech command 0 through 9 data set. So this data set actually was built by Google in 2017, and in this data set we will get the larger amount of audio clips, like around this data set consists of 65,000 of the clips, audio clips for taking as an input to your research. So this 65,000 of the clips, each clips is having around 1 second long duration, and uh, each clip contains a 30 different words spoken by the thousands of people. Means what? Suppose hi, hello word is there. Hello is one of the word, and for that hello word, not only a single voice is present in this dataset. It consists of the multiple voices or thousands of the voices which are spoken by the different people to give as an input to your system. As all of you know, if we are working with the neural network, we need a larger amount of input or the data set. So if we provide the larger amount of data set, then only we can get the accurate output, and the accuracy we will get good. So best accuracy we can achieve. So I just wanted to tell here, as we can have the 30 different words in this system which are spoken by thousands of people, then we can get a larger input to our data set. And here one thing was there in this data set, you can search in Google, you will find out this. So the thing was that, like the whatever clips they have recorded, all these clips are with the recorded with the phones or the laptop, like in the realistic environment they have recorded the clips. It is not like that they have maintained a particular environment and they have recorded the audio. Okay, so that is the one point, like positive point for this. Why? Because the main advantage of this recording in the environment, realistic environment, is that, so this application, whatever application or whatever research you are going to do, that will be used for the real-time applications as well, so that we can use the outputs which we are generating in the real-time world in the industries or as well. So that's why it is a useful data set for any like if we are performing any of research in the NLP. Okay, so I have few of the like clips which I have downloaded from this around these 65,000 clips for this data set. Okay, So as I told you, this customized dynamic time wrapping algorithm has introduced two main concepts, that is wildcard pattern. See, you can see here, these are the patterns are already maintained. So such a patterns are stored in the data set. Once the person is trying to say something, so the system will try to match the word which person is trying to say with these patterns. So that's why they have introduced the concept of wildcard pattern in the customized dynamic time wrapping algorithm. Okay. So few of the test results I wanted to show you here. As I told you, in this data set, 1 minute, they have like 30 different words spoken by different people, thousands of people. So what accuracy is achieving in that case? You can see here, if that particular word or the audio is present in the data set. Three scenarios I just wanted to tell you here. If a word is present in the scenario, then system was giving the matching or recognizing percentage as 100%. Similarly, if we are giving as an input to the system as a word which is not present in the data set, means new word, and that word is spoken by the person whose audio is already present in the system. So in that case, the system was giving an output as a 70%. Okay. Similarly, if we try to test the system with the word which is not present in the data set and the new user whose voice is also not recorded in the system, so it was giving the less accuracy in case of DTW. So these are some of the drawbacks of the previous system. You can see, like here if we are giving the new word or the new audio, the system is giving the very less accuracy. You can see the multiple outputs I have, like in this second output you can see, again if new word and the new user is there, then system was giving very less accuracy, that is around 30%. In this third scenario also you can see, if for the new words or the new data set, the system was giving very less accuracy, which is 20%. So what is the drawback over here? The drawback is that these systems are straightforward, so they are not trying to recognize the new word. So our system are not having intelligence to recognize the new thing, whatever coming as an input to that system. So that were the drawbacks. So that's why I just wanted to show these results to you. So what were the drawbacks which were present previously? Okay. So these are, so you can see here, by comparing all these three, only 25% accuracy or 20% accuracies are achieving by using these like few of the very few accuracies achieved through this DTW. So that were the drawbacks in the previous systems actually. And now you can see here, one more algorithm I wanted to discuss with you is modified k-means with self-organizing network. So here, as all of us know, 1 minute, I think some problem. Okay, sorry. So here the problem was there in normal k-means. All of us know now the k-means algorithm is very old. The people are not. We cannot use normal k-means for any larger applications or in any real-time applications. We cannot use this normal k-means algorithm. So I just wanted to introduce here one the if somebody is doing research in the k-means with neural network, so they can try to find out some of the methods which are available with the neural networks applied along with the k-means algorithm. Okay, so these are some drawbacks of previous k-means was there. As all of us know, we are studying it from like bachelor's degree, that we had more computation time for larger applications or the industry related applications. The computation time was less, and again each time if we are trying to classify anything, not only speeches I am saying here, if we are considering any data or we are if you are working on any data, so each time you need to define the cluster at the start, cluster centers at the start, like these many clusters centers, these two cluster centers are there or these five cluster centers are there. So these are some of the drawbacks were present in the normal K-means algorithms or variety of algorithms which were developed in the K-means. But what I want to say here, if the modified K-means algorithm with the neural network can be used, so the main like positive points of this neural network is that like we do not need to define the number of clusters in this case of K-means with the SOM network. The clusters are randomly decided by the system. Why? What is the main advantage of this? That the advantage is that if we are using data of like which consists of like not thousand, in more than thousands of points are there or audios are there, we cannot define the cluster centers at the start for a large amount of data. So in that case this neural network concept can be helpful. So as randomly the um, system will try to find out the cluster centers, or it will randomly decide the cluster centers at the start. So that is the main positive point. And one more positive point is that is the computation time. Okay, for example, if I'm using the data in lakhs, like 10 lakhs audios I have with me, and these 10 lakhs audios, if I try to work out with the k-means algorithm, it will take like around 3-4 days, or it may not work. In my case it may not work normal gaming algorithm, but the computation time also get reduced due to the neural network techniques as compared to the normal techniques which we are using previously. Okay, so that's why the neural network is, as I told you at the start, is a trending era currently, which is developing the automated system in the industries as well, and in which there is no need of human intervention is required. So that's why this concept of neural network comes again in the k-means also for classifying the data, not only the audio data but we can say other types of data as well. So here I just have created one small like flow how this k-means with the neural network works. You can see here initially if I have taken the input audio and I want to classify this audio, I want to recognize this audio by using this k-means k-means algorithm with SOM neural network. So here input audio is taken as an input, and then and the whatever audio features are present in this audio. Here I have considered audio because of NLP, but you can take, suppose if you are working with any data, so you need to do your algorithm according to that. So input audios are taken as an input, and then what the required features are there in every data. So those features get extracted, and then the SOM network will start from here. So you can see here if somebody has worked with this SOM network, so here I have considered the number of iterations as a 100. So till this 100 iteration my algorithm will go on like working actually. So to recognize the word or audio, so you can see here the iterations taken as in 100, and then it will try to classify those. After 100 iteration the system will try to classify those audios in the categories. Okay, so that I will come to know about what is the input audio provided by the user and what is that user want to say, so that my system can recognize it. So and so that is the just general flow for the system. So again, as I have told you this data set, the previous data set, as I have mentioned, this SC0 through 9 data set somewhere. Okay. So if we use that data set and we divide that data set into the 3 dictionaries, like why 3 dictionaries I have divided here? Like in every dictionary, we can maintain a similar type of words. This dictionary 1 is my first data set, sub data sets we can say here. So here I have maintained the similar types of audios. Like in dictionary 1, different similar types of audios. In dictionary 2, other similar types of audios, and in dictionary 3, the other similar types of audio. Okay, so we have if we take the input like audio, and then so once we are giving the input to our system as the audio, so we will get such a waveform of the audios. Okay, And after, as I have mentioned here, the algorithm, once we are giving an input to the audio, the feature get extracted. Now after extraction of the features, the audio will look like this. Is a general sample audio. I just have taken one sample which I have given to this system, and after extracting of the features, the audio waveform will look like this. And see, you can see here the generation of waveforms is present in the after extraction of features present in this the values, like these are the features of the waveform which we have provided as an input to calculate. Why this is actually internal operations which occurred inside the, technically we can say these are the operations which are occurred inside the system, so that system can find out the comparison in between the input waveform and output, whatever output waveform we have generated by using this uh, modified k-means, or we can say k-means with the SOM network. So you can see, the if I tried the same dictionaries or the same words with normal k-means algorithm, it was giving some less accuracy and it was requiring more time as compared to the if I am using the neural network concept for SOM network for my k-means, modified k-means we can say. So such a like things are there in neural network which are giving the good quality outputs as compared to the normal techniques which we are using in the past. So that's why we need to introduce the recurrent neural network concept in current era, okay, which is having the demanding position right now. Okay, so that's all about like what are the positive points of neural network as compared to normal techniques. Okay, now we will just go for one more technique, that is if we are giving the speech input to the system and we will try to generate speeches from that speech input only. So as I told you, the GAN is a good like the best method for not only speeches, but you can use this GAN to other methods for on which you are doing your research, neural network. So this is the best method for large amount of data if we have as an input, so we can use this. So we will go with one by one, like what are the GANs are there and which GAN, like which GAN method is best, is performing best for like we can say for any data, any type of data if we are providing as an input to the system. Here as a NLP I have considered only the audio data actually. Okay, so we will start with that. So before that, just can you give me 1 minute so that we will continue only for 1 minute, ma'am.
Okay, ma'am.
Okay, just only 1 minute so
No
that.
problem.
Okay. मला येत नाही उत्तर, नंतर विचारते मला. ते लोकांना हे ना theoretical पाहिजे असतं, कारण की त्यांना आहे ना असं काय कळणार म्हटलं ऐकून नाही आपल्याला आउटपुटच आहे डायरेक्ट. काय माहिती चांगलं झाले. कंटिन्यू कर. सूज वाटते बघा ना आता है ना Okay. So, ma'am, can we continue or still?
Yes, ma'am.
Yeah, yeah. Okay. So till now, if anybody is having any doubt, or you can ask me before going for the GAN. I just wanted to tell some technical perspectives of GAN as well, along with it. Okay. So we will start it. Okay. So, as I told you, the various the GAN or generative adversarial networks are present right now. So these are like, for example, we will discuss some of those here. Like one is WaveNet, WaveGAN, and MailGAN. So these are a few of the techniques present for the GAN. So as I told you, the general what is GAN, that is generative adversarial network. The people who like are not doing research in GAN, so just for them I have prepared this slide. So what is GAN actually? GAN is nothing but generative adversarial network. Now you can see this is a general architecture. As I told you, there are two main components are available for every GAN architecture. One is generator, which is very important, and discriminator component. So these two GAN is completely depending on generator and the discriminator. The main task of the GAN is to generate the audios. Okay, and the main task of this discriminator is to find out whatever audios are generated from generator and from the given input data or the training data, you can say, are either real or fake. Okay, so it will try to recognize those, and whatever real outputs are there, so that will be considered. Okay, so you can see here the generator is also generating few of the audios by adding some noise into it, like we can say random noise, or suppose inputs are provided to the generator with the noise. So whatever the audios are generated from the generator are given as an input to the discriminator. Along with that, discriminator will also take the inputs from the training data, and then the outputs which are generated are find out by using discriminator whether they are real or the fake. Most of the people who are doing the research in this area, they might be knowing this fact. Actually, the same thing I have mentioned over here. Okay, now we will start with the wavenet. Okay, wavenet is one of the type of GAN. It is also consist of these two components like generator and the discriminator. So it is normally, this wavenet is an audio generative model which is based on pixel CNN. Okay, and this generative model, for the generative model, each audio, suppose if we consider as an audio, so each audio sample is conditioned on a previous audio sample. But what are the drawbacks actually in this wavenet? It was the previous method for the GAN, which are already implemented and used by multiple like researchers in different areas. So what was the actually the problem over here was that the there is like the receptive fields or the output field, which we can say, so it is needed to improve. It is very less, so that the outputs, like whatever outputs they are getting, that is they require the many layers in order to increase the receptive field, or we can say the output. So that was the problem with it. So after that, some of the researchers have tried to find out to add like dilated convolution, we can say dilated convolution layers to get a large receptive field, because as the data we are having, that is in large amount, so whatever output we are getting, that should be that is also in the large amount, so we need a large receptive field, and with the few layers of the convolutions we can use. So for that purpose, for reducing the number of layers and the increasing the output receptive field, they have used the dilated convolution here, the concept of dilated convolution in case of wavenet. So these are some of the sample original input waveforms which are available already, and what are generated so the and this is a generated waveform for the given sample input waveform. So just for the comparison purpose, how this this wavenet is giving the output or the accuracy that I wanted to show you over here. That you can see here, the maximum it is trying to match the audios which we are providing as an input to the system the with the output which we are getting. So this output is trying to match up with the input audios in case of wavenet. Again, the next GAN, that is waveGAN. Okay, so some of the issues, as I told you, in the wavenet were present. Okay, so waveGAN has tried to solve those issues. This is the next model of the GAN, one more model, that is waveGAN, we can say. So some of the challenges were there. So these challenges are tried to solve by using this waveGAN. So what were those challenges? Okay, so the challenges was there was the overlapping frequencies issue. If we are frequencies means what? If we are providing any audio to the system. Okay, so in that case, if we are providing that audio to the system, in wavenet, what was the problem? That the frequencies of those audios were overlapping. In output, whatever output we are getting, the frequencies were overlapping. So that issue was resolved in the waveGAN actually by so which method they have used, that is phase shuffling method. So this phase shuffling method is like windowing. You can see in this here in this diagram. So it is a windowing method. So where this particular window is shuffling after some time, so that whatever the issue of the overlapping frequencies was sorted out by using waveGAN. And one more thing they have improved as compared to the wavenet was larger upsampling factors. So the upsampling factors in case of GAN like wavenet was 2, but here they have improved it up to 4. Okay, and waveGAN has used the one-dimensional filters only. So you can see here, this is just diagram I have shown. This is a one-dimensional filter of length 25. Okay, so these three main fundamental aspects was there in the waveGAN, which are best as compared to the wavenet. And again, this is the output. One real one input audio you can see, which is provided to the waveGAN, and this is the output audio, that is output audio waveform which we have generated by applying on this. Okay, so these are just the outputs from the audios. Again, the next method, that is male GAN, which come into the existence. Okay, so this is one of the good case study actually, and it is having good accuracy as compared to other GANs as I found. Okay, so again, in case of male GAN, the two main components I just wanted to tell how these two components, that is generator and discriminator, how these two components works actually, what is actually present in these two components in detail I wanted to tell you here. So you can see this is a generator architecture. This is the first component of the male GAN or the generative adversarial network. You can see what it contains. It consists of the one convolution layer which is followed with two upsampling layer. So here this is first upsampling layer and this is second upsampling layer, and each upsampling layer is followed with the residual stack. Okay, and what is present in this residual stack is that dilated convolution block. As I told you here, to improve the wavenet accuracy or wavenet receptive field, not accuracy, receptive field, they have used the dilated convolution block. This is the dilated convolution block to improve the receptive field or the number of layers, convolution layers which we require for GAN will get reduced due to this dilated convolution block. So so this is general architecture for the convolution layer, for the generator, and then again it is followed with the next convolution layer. So in this way the male GAN generator architecture is present. First we have the convolution layer which is followed with the two upsampling layers. Okay, and then again the next convolution layer will start. So this is a general architecture for generator. And what is the discriminator architecture now? The second component of that is the discriminator. So what is present in this discriminator architecture? You can see here, in case of male GAN, we have three different discriminator blocks. which is not present in the previous GANs. They have only one discriminator block, but here they have used the three different discriminator blocks. Why? So first discriminator block was used for taking taking as a raw audio input, as in whatever audio we are providing, that will be taken by input by the first discriminator, and then it will extract the features from the audio and generate the output. Okay, and then the second discriminator and the third discriminator block is trying, like it will uh, take an average pool, like average pool audios which are generated from the raw waveform, and then again they will try to find out the features or extract the features and the output. Now what is present in this every discriminator block? Three discriminator blocks are there. So what is present? What is the structure of it? So it consists of these layers you can see here. First, raw audio waveform or raw waveform or raw audio we are taking as an input, which will goes to the first convolution layer, which is needed for the feature mapping. Again, it is followed with the four downsampling layers of discriminator, and then again we have two convolution layer in the discriminator. One is for feature mapping and other is for getting the outputs. Okay, so in this way these convolution layers inside the discriminator will work. First convolution layer will take the raw input, and then it is used, as I told you, the downsampling factor is 4. So this layer is used for downsampling or the mapping of the features with the factor of 4, and then the next two convolution layers are used for actual feature mapping and getting the output in case of discriminator. Okay, so in this way this is a discriminator architecture for male GAN. The similar thing I have mentioned, like written over here, whatever I have mentioned right now. So three discriminators are there, that is D1, D2 and D3. Out of that, D1 is working as a taking as a raw input to the system, and D2 and D2 are operates on the raw sample, which is downsampled here, or average pool we can say, by the factor of 2. They are 2 and 4, so they are working here downsampled audio or average pool audio we can say. So, and then as I have mentioned, is the structure of discriminator. So that is, these are the layers for that. Again, I just wanted to show you here one case study, that is we can say the input audio, or which we have taken as an input sample audio. I just wanted to discuss over here for any of the word, and whatever generated audio by the male GAN. You can see here the comparison or the audios with like less differences, like maximum it is trying to find out the output audio as like a input sample audio. This is the input sample audio and this is the output or generated sample audio for the male GAN. So for this comparison of these frequencies, you can see these are the frequencies or amplitude and time I have mentioned over here. So for that comparison we can use this minimum optimum score techniques. So this technique is used for comparing the audios. This is a good technique for comparison in between audios waveforms. Okay, so as I mentioned you, like what are the three models, whatever I have shown you right now. So these are the these three models are there: wavenet, waveGAN and the male GAN. Okay, so here these I have these some of the like accuracy parameters from if I have applied that SC0 through 9 dataset on few audios. So what I found is that the accuracy which was achieved by the male GAN was good, that is around 92.1%, which were less which were less in wavenet and waveGAN. So wavenet was performing like around, this is general average accuracy I have mentioned over here, at 78% we can say, and for waveGAN it is 83.4%, and if by using the same inputs we will get the good accuracy in case of male GAN, like whatever audios are generated by the male GAN are having the good accuracy, so for which is around 92% according to the input I have provided. So you can see here, and these are the comparison analysis for male GAN. So we can say that male GAN is performing better as compared to the waveGAN, and waveGAN is performing better as compared to the wavenet in case of audio processing. But if we try to like find out the system with other data, so you may get some different outputs, or depending on the data which you are providing, whether it is like good quality of data or a data set, so it will be giving the accuracy according to that. Okay, so it's the same thing I have mentioned over here, that is mailgun is giving the good accuracy. Okay, so one more GAN I wanted to discuss over here. Like as I told you, the mailgun was given a good accuracy in case of audios. So, but there are again few drawbacks are there for the mailgun as well. So that can be overcome by some different advanced GAN as well. So, what are the drawbacks were present in the mailgun? So you can see here the mailgun. In mailgun, the generator G, we can say G as a generator, takes an input as a mail spectrogram or audios, we can say, and generate a signal in full frequency band. Actually, in case of mailgun, the inputs which were taken by the generator, they are providing the output in the full frequency band. Means it is not providing the output in like generator signals in multiple frequency bands. It is providing or generating the signals in a full frequency band in case of mailgun. Okay, means only in a complete frequency band they are providing the outputs. And so as the outputs which we are getting, audio output that are in the full frequency band, we do not need to sum up. Sum up means what here? Like normally if we say we are using the multiple frequency band, not a full frequency band. So in that case, in multiple frequency band, we need to sum up the output at last. Like we need to sum from all the multiple frequencies and we will get the actual output. So that concept was not there in the mailgun. But if we consider some more advanced GAN with the mailgun, what is found that they are using the multiple frequency band instead of using the full frequency band as like a mailgun. Okay, so the signals from each of the frequency after getting the output or what after getting the audio output or any data output which we are giving as an input, so they need to sum up at the last. Okay, in case of advanced mailguns, but the issue is that whatever accuracy which we have achieved in the mailgun was less as compared to the um, advanced mailgun, because it is trying to match maximum audio with the input audio, this advanced mailgun. So what is actually this advanced mailgun do? In advanced mailgun, the generator G takes an input audio and generates a signal in multiple frequency band, not in a single frequency band as like a mailgun. And the predicted audio signals in each frequency band are sampled and then sent to the synthesis filter. Okay, and then signals from each frequency band after synthesis filter, after sending it to the synthesis filter, whatever outputs they are getting, that will be summed up to get a single audio. Okay, so the main like task here is that the generator will generate the output in multiple frequency band, and at last we need to sum up. And what discriminator will do here in this case in advanced mailgun is that the discriminator treats a full band signal as an input, and several discriminator are there. Several means, as we have seen in mailgun, we have 3 discriminators in such a way that here multiple discriminators are there to discriminate the distinguish, we can say, the features, okay, which are originated from the generator. Okay, so the main task of discriminator over here is to distinguish the features which are originated from the generator in different scales. Okay, so this is all about the advanced mailgun. So you can see here, if we compare by using the same data set, the mailgun with the advanced mailgun, generative adversarial network, it is found out that again the advanced mailgun have improved their accuracy as compared to the normal wavegun method. Okay, so which is very good actually. So and which is trying to find out the audios which are more closer to the input audios. So you can see here the comparative analysis, just by taking some of the few random input, we got this output. Okay, so I just wanted to say here, if like whatever things I have told you today, so from that I just wanted to tell that if in case of normal text to speech techniques, if we try to implement it, it is not giving the good accuracy in case of larger data sets. But if we consider the customized dynamic time wrapping algorithm with some neural network techniques, so it try to improve the recognizing rate, like speech recognizing rates, not only speech recognizing, I want to say here, for any input audio or any input like other types of input we can say. So by using self-organizing network, if we try to find out by using dynamic time warping algorithm, so in that case it is giving the good accuracy as compared to the straightforward methods of generation of speech. Again, we have discussed about the k-means with the self-organizing neural network. So if we use the self-organizing neural network in case of k-means, with the k-means, you can search out, multiple papers are available on it. Right now people are doing the research in this SOM also by using k-means for they're implementing their various techniques. So in that case it is giving the good accuracy due to neural networks again. If we compare the GANs, the male GAN we found the good accuracy, and again if we compare that male GAN with some more advanced GAN, so these advanced GAN are again achieving the some more good accuracies, which are still the research is going on for this GAN to improve the accuracy. So these are just I just wanted to tell you over here. So these are few of the methods which are available if you are doing any research in the neural network or recurrent neural network. So you can use these methods, and some of the papers I have like with me also. What are like multiple papers are with me, so we can, if you want any help for your research, in if you are doing any research or teaching the same subject, so we can like collaborate, and we can improve the, like we can try to implement any new systems for the future. Okay, so because I'm also having the interest in the same domain like neural network, if we try to implement any new system which can be used, or we can use in the real time aspect, so for that purpose. And these are some of the references which I have right now, some papers from which I got a few of the data and few of the methods which I have implemented. Okay, so this is all about which I wanted to tell to all. So if anybody is having any doubt now, you can just ask me. I will be there for clearing your doubts, or if you want any technical help in this for implementing these techniques. So I have few of the implemented algorithms, so we can discuss it. So that's it from my side. If anybody is having any doubt, you can ask me now.
Participants, any doubts you have, please ask. Please ask any doubts, participants to speaker.
Or if you, yeah, or if you want to like do the, if you want any techniques, so that we can connect and collaborate for that also.
Can you share your mail ID?
Yes ma'am, sure, sure, I will share here, because my personal mail id is geet.121 at gmail.com. And if you need any topic, like any work on the same area, not only, I'm saying not only in the neural network, in the sorry, not in audio synthesis or the speech synthesis or NLP. If you are working in neural network on any topic, whatever things I have, I can like we can like connect for that, and whatever knowledge you have we can share, and we can work simultaneously in neural network also. Even if you are not working in the speech area, you are working in some other area, so that will be also fine actually, no problem.
Thank you, Geeta.
Yeah.
It was a very informative session. Jyoti here.
Yeah, ma'am. Thank you.
Very informative session. I think most of them now are working in GAN,
Okay.
and RNN is the most popular one now.
Yeah, that's
So I think most of the participants, at least it would help them,
Sure,
like
ma'am.
it will be a way for them to get into their research.
Correct,
It will
ma'am.
surely be an input for their research. It was a wonderful talk, Geeta.
Yeah.
Thank you so much for accepting our invite.
Yeah. Also, ma'am, I would like to hear thanks to Dr. Jyoti Prabha ma'am and Dr. Kishore Kumar sir for continuously taking like giving me the proper way for like joining the sessions and for invitation. So they have really coordinated really like good. It is really appreciable from my side. And
Thank you, ma'am.
not only them but for all the coordinators who are really working for this workshop. It is a great workshop actually for like you have planned it for like from 6 to 18. It is really great so that a lot of knowledge can get to the people. So I would like to thanks to all the participants as well, like they are like patiently listening and whatever things I am trying to say, and also like the management of NIT Warangal and Kankriya Institute of Technology and Science and like ICT Academy. I would like to thanks to all for giving me an opportunity to present my skills in your institutes. So thank you so much to all. Um,
Thank you,
that's
Geeta.
it,
Thank you,
ma'am.
ma'am.
Yeah.
Participants, do you have any doubts? If not, we can wind up the session.
Ma'am, Deepak Kumar sir has have a meeting. That's why sir cannot attend signing this section, ma'am. Right now.
Okay.
Okay, sir said to thanks to Geeta ma'am.
Yeah. Geeta ma'am, thank you from Professor
Yeah,
Kishore
yeah,
sir.
yeah. Yes, ma'am. Yes, surely I will contact with them.
Yeah.
He was also
Thank you.
taking-
Thank you very much, ma'am.
Yeah, ma'am. Thank
We
you.
hope that we'll be having you for future sessions and activities.
Yeah,
also.
sure, ma'am. We will collaborate and we can like improve ourselves also and to like
Yeah, for
research as well. Yeah.
Thank you so much.
Yeah, thank you.
Thank you, the participants. The next session will start at 2 o'clock and it will be by Associate Professor Dr. S. Geeta, Associate Dean from Belur Institute of Technology University, and she'll be talking about malware detection and visualization techniques. So those who are doing research in the malware or anybody is planning to do research in that classification, deep learning and other things, it will be great benefit for you. So I wish all of you join the session sharp by 2 o'clock. Thank you all. Yeah, thank you, Geeta. You can disconnect now.
Yeah, ma'am. Okay, sure. Bye.
Bye.
Oh, hello.